So my family raises cattle. I'm very much aware of how we manage our irrigation systems. If you look at our ski resorts, when they're opening, when they're closing, if you go look at Causey Reservoir right now, or the Great Salt Lake, we don't have Antelope Island anymore. We have the Antelope Peninsula.
Especially in very arid states such as Utah, because we rely very heavily on our snowpack over the course of a year, because we are a desert state. In past history, we have this very high amount of snowpack to rely on as we get into our very hot summer months. That has been able to sustain us, and as we are seeing lower and lower levels of snowpack, there's a big question as to how are we going to continue to sustain all of the development that's occurring? How are we going to sustain things like our crops and just drinking water in general? We've seen especially with our Great Salt Lake, it's a very shallow lake, and so it's very impacted by those times where we aren't getting enough moisture into our rivers that lead into that lake.
And you also realize that our population is supposed to double by 2050. And then you look at how underpriced our water is and how we don't really encourage conservation. We're going to have a real tough discussion to have.
As we think about our diminishing snowpack, is thinking about the actual amount of area that's being impacted. And so we can think about something, an area such as the Colorado River Basin, and those headwaters, which are starting as far north as Wyoming, and even more north, and those headwaters are being fed by snowpack. And then the river system starts to flow southerly, and then we get into more arid areas where we have these huge growing metropolis areas such as Las Vegas, Phoenix, all these very dry types of big cities that continue to grow and rely on the headwaters that are coming from more north types of areas that are fed by snowpack. And so as we see less snowpack, the question is, how are we going to continue to support these massive developing areas, and especially with the actual Colorado River Basin, we're seeing that water is gone before it reaches the sea, where it used to be a very thriving kind of river delta entering the sea, and now it's just dried up. So probably the very most important thing to consider is we don't really take into consideration that we're using our water at a quicker rate than we're actually able to supply it through our snowpack. And so we have the issue on both sides. We have diminishing snowpack in the north, feeding less water into these river systems, and then we have more freshwater use in the south in these arid regions, and we're going to get to a tipping point where we can no longer support the growth that's occurring in these areas.
So there's a few things, and there's some misconceptions about how to best save energy. One of the best things you can do as an individual is change your thermostat settings. The primary driver for energy in a home is your air conditioner, your dryer, and sometimes your refrigerator, depending on how old it is. So if you change your thermostat settings, that'll make a big impact both on your natural gas bill and your electric bill. The other thing that's become much more accessible over the past couple years is LEDs. LED costs have gone down and their efficiencies have come up. So it's really at the point where people can afford it and they pay for themselves very quickly.
So the issue, if you think about it more holistically, is not just the snowpack, but the lack of fresh water that we have available to support our growing population. And so if we're going to actually be able to adapt, we need to start thinking about how we use our water resources and think about, even just the size of our lawns. Actually, we use so much water just watering lawns that we hardly ever use oftentimes. So even thinking about how we're going to be more efficient with our water use as we start to adapt to a drier kind of climate, because as we've seen, the last 10, 20, 30 years of lower and lower snowpack, it's starting to become the norm, and that's something we're going to have to face if climate change is to continue.
We're 10 years into pursuing our carbon neutral goal, so what we're doing is retrofitting the entire campus to be electrified and then sourcing that energy renewably. Some of the more exciting projects I've been involved with are our Davis solar array. It's 1.8 megawatts. Our first ground source field, which is a type of geothermal energy that we use to heat and cool our buildings. We're always doing lighting projects, upgrading compressors, putting in new drives, that kind of thing.
We know that climate change, if we're going to actually get into the science of climate change, it's truly impacting that moisture that we receive in our mountainous areas, and then therefore our snowpack. If we're going to make widespread change and start to reverse the effects of climate change, it needs to be political at this point. Because we have very polarized ideas of what climate change is and why it's occurring, and a lot of people choose to ignore that science for some reason.
We're going to have a real tough discussion to have unless there are some serious policy changes. There's this debate and these discussions about, well, all we need to do is educate people, but a lot of studies have showed that education is only one piece of the puzzle. And if you look at municipalities that have had to deal with this kind of stuff, like Tucson, for example, they have a tiered structure of utility rates for water, where the more you use, the more expensive it gets per unit. And that puts an economic incentive on the individual. So instead of just relying on people's sense of doing the right thing, I suppose you actually attach a dollar value to it. I personally think that's the way we're going to have to go.
Yeah, make it a personal issue.
Mm-hmm. And then the other big step that we're going to have to take, that's going to be a large political battle, is starting to meter secondary water use. Because secondary water, people use it to water their lawns. The cost for that is constant, and it's associated with your property value. There's a calculation that goes in there, and it's how much turf do you have, and how many square feet of turf, and what's the tax value of your property, that kind of thing. But we don't meter that at all. So I don't know how much water I use to water my lawn. There's been some test pilots to put in meters to help see how that affects people. And so there's a question there of, how does knowing how much water you use affect how much you use? And how does paying for it affect how much you use? But given those two factors I mentioned, this kind of declining supply and increasing population, we're going to have to go down that road. Now at the university, what we're trying to do is get ahead of the curve on water conservation, so when those policy changes come, it doesn't hurt us as bad financially.